Hey everyone, so in this video we'll be introducing the concept of a transpose of a matrix. Now if you're not familiar with basic matrix notation or what the order of a matrix is or what an element of a matrix is and so on, please check out some of our other videos on matrices and that should become clear. So to understand a transpose, let's start by first looking at a simple matrix here. So what you see here is a matrix with 2 rows and 3 columns. So the order of a matrix is 2 by 3 and I'm going to call the matrix matrix A. Now the transpose of the matrix A is denoted in this particular video as A bar or A apostrophe. This is a notation that's fairly common. Another notation that you might have seen in books or in other classes is where A is denoted, the transpose is denoted as A with a T as a superscript, right? So A T for A transpose. Now in this video I'm going to use A bar, but I just wanted you to be familiar with a different notation. So as you can see already from the shape, A bar looks slightly different in shape from A, and that is the case for rectangular matrices. And so what a transpose of a matrix is in the transpose, or when you transpose a matrix, the rows of the transpose are the columns of the matrix, and the columns of the transpose are the rows of the original matrix, right? Now that will become a little more clear as we compute the transpose of A. Another way to understand this is, take the matrix A bar. So the elements of A bar are Aij bar. Each element of A bar, called Aij bar, is equal to Aj, right? So Aj are elements of A, right? Small a, if you're familiar with matrix notation, denotes with the subscripts I and j, denote the elements of A. So what you can see here is Ij and Ji, right? So if I is 1 and j is 2, then A bar Ij indicates the first row, second column, and that is equal to Aj, which means second row, first column. That's what it means. So now even if you're a bit confused, just hold on for a second, and we're going to go and compute the transpose of this matrix A, and as we go through the steps, what I mean by Aij bar equal to Aji will become very, very clear. So let's start by trying to find the first element of this transpose, right? This one. So that's A bar 1 1, right? But before that, another question: what is the order of this matrix? So because the rows become the columns and the columns becomes the rows, this one has 2 rows and 3 columns. So this should have 3 rows and 2 columns. The transpose of A should have 3 rows and 2 columns. So the order is basically flipped, right? So when you take the transpose of a matrix A, then the transpose, which we are calling A bar, has the exact opposite order as the matrix. If the matrix has order 2 by 3, then the transpose has order 3 by 2. If the matrix has order 5 by 2, the transpose has order 2 by 5. What happens if it's a square matrix? Well, the matrix is order 2 by 2. You flip that, you still get 2 by 2, right? Okay. So now let's start to find the first element here. So the first element of the transpose, right, which I'm calling A bar, is A11 bar, right? So how do you find the transpose? A11 bar, which is A bar Ij, where now I is 1 and j is 1, right, is, because you know A is Aj, but j is 1, I is 1. So A11 bar, which is this, is actually this element, A11, right? So it's very simple. You take this first element and it becomes the first element of the transpose. Okay, superb. So now I'm going to go row wise for the transpose. So now I'm interested in finding out this element, right? A12 bar. So how do you find that? Well, A12 bar, right, Aij, so now I is 1 j is 2 is equal to AJI. So j is 2, I is 1, so it's equal to A21, right? So you go back to A, second row, first column, that's A21. So A12 bar is just this A21. So this A21 comes here. So that explains what I mean by Aij bar is equal to Aji, right? The indices are just flipped. You just take the opposite or the flipped element. It also shows another concept, right? The rows become columns and the columns becomes rows. What does that mean? Well, the first row of the transpose is 2, 7, right? That's row 1 of the transpose A bar. That is the first column of the matrix A. So the column of this becomes the row of this. Right? That's what this means. Okay, let's find the next element. And this will become even more clear. So now we want A bar 2, 1. Second row, first column. That's the element you want. So A bar 2, 1 is, flip it, A12. What's A12? A, first row, second column, 3. So A bar 2, 1 is 3. Right? Now A bar 2, 2. So A bar 2, 2, same concept, A bar 2, 2, flip it, it's still 2, 2 is equal to A22. So A, second row, second column is A22, that's 1. So this is 1. Superb. And now you say that the second row of the transpose A bar is equal to the second column of the matrix A. So again, the row here is the column here. And now we'll find the third row of this. So now what do we want? We want A31 bar, right? And you've already guessed it by now, I'm pretty sure, but let's do it. So A31 bar, flip it, is equal to A13. So A13, first row, third column. So A13 is 8. So A31 bar is 8. Good. And the last element, A32 bar. So A32 bar is, flip it, A23. A, second row, which is this, third column, 7. So A23 is 7. So A bar 32 is 7. And again you see that the third column of A has become the third row of A bar, right? So that's the transpose. Now again, just look at the now that you have seen the entire transpose, let's just look at it. I've already gone through what Aij bar equal to Aji means. That should be very clear. But now again, explaining rows become columns and columns becomes row. For this matrix A, the rows are, the first row is 2, 3, 8. That has now become the first column of A bar, 2, 3, 8. The second row is 7, 1, 7. That's become the second column, 7, 1, 7. Similarly, if you look at it column wise, the first column of A is 2, 7. The first row of A bar is 2, 7. The second column of A is 3, 1. The second row of A bar is 3, 1. The third column of A is 8, 7. The third row of A bar is 8, 7. So the columns of this are the rows of this, and the rows of this are the columns of this, right? And that explains why the rows of the matrix A become the columns of the transpose and vice versa. So I think you've understood hopefully very clearly what a transpose is. You should be able to do this now for any matrix because it's a very simple principle. As long as you remember the Aij bar is equal to Aji, you should be sorted. It's just a very systematic approach. And then you can just check it again by making sure that the rows here are the columns there and vice versa. So let's do an example to cement this a little more. So you have this matrix A here. It's a square matrix. 2 rows, 2 columns, 2, 5, 3, 1, right? Order 2 by 2. Now I'm trying to find the elements, these two elements. That's A bar 1, 1 and A bar 2, 1, right? And I also want to find the order. Okay. So let's start with the order. It's very simple. The order, as I've explained to you, you just take the order of A and you flip it. That becomes the order of A bar. But 2 by 2 is 2 by 2. So the order of A bar is 2 by 2. Simple, right? Okay, superb. So now what we want to do is find A11 bar and A21 bar. Let's start with the first one. So A11 bar, right? Now we know that Aij bar is Aj, and I've just written it here, so just remember this and that will get you through transpose whenever you do it. So 1 1, so go back here and take 1 1 because I and j are the same, 2, and that's 2 here. So that's A11 bar sorted. Second element, what do you want here now? You want A bar 2 1. So you flip it. A bar 2 1 is A 1 2. So it should be this element, right? It is. So you've got that. And an easy way to check it, the row here has become the column here. Simple, right? So now why don't you go ahead, pause this video and try to find these two elements, right? Try to find A bar 1 2 and A bar 2 2, right? Pretty sure you've got the answer already. So showing it right now, and it's 3 1. This row has become this column. So if you look at a square matrix, and this applies for a 2 by 2, a 3 by 3, a 4 by 4, any size square matrix, the diagonal elements, in this case 2 1, are unchanged because the index of the diagonal element is the same, right? A1 1, A2 2, so I and j are the same. So even when you flip it, I and j are the same. So the diagonal elements are unchanged, and the off diagonal elements get flipped, right? Okay, so now that you're done with this case, let's look at another case, right? Okay, so now you have a matrix here B. You can see it's a row matrix, so it's got 1 row and 3 columns. And I want you to find the transpose B bar. So first let's start with the order, right? Okay, so order should be very simple, 1 by 3. So what's the transpose? You flip it, right? 3 by 1. So the order is 3 by 1. Now let's find the first element, B bar 1 1. Now again, very simple, B bar 1 1. So you flip it, it's B 1 1, which is this element. So it's 2. And then you have B bar 3 1. So that's third row, first column. Flip it is B 1 3 minus 1. And so you're done with that. Now can you find the remaining element? You should be able to. It should take only a fraction of a second, and that's 5. Now let me ask you another question. What is B bar 1 3? Right? You found B bar 3 1. What's B bar 1 3? So you use the flipping rule. B bar 1 3 is B 3 1. Right? Simple. But the problem here is B is a row matrix. So B does not have a 3 1. So B bar 1 3 does not exist, right? So in case you see something like that or a question like that, just remember that especially in rectangular matrices, in a square matrix you will find a corresponding element because it is square, but in a rectangular matrix, when it's flipped, right, here you have a B 1 3 which does not exist here. Just keep that in mind. Okay, so let's do one last case. And in this case we start with a matrix C and we have a column matrix. So it's got 2 rows, 1 column, 2 by 1 matrix. Find C bar. Now let's do it in one shot. So first find the order. What's the order? 2 by 1 is C, so C bar is 1 by 2. So that's good. What's the first element? The first element is always very simple. 1 1, flip it, it's 1 1. So C bar 1 1 is C 1 1, which is 2. And C bar 1 2 is C 2 1, which is 3. Now again, for a column in a row matrix, it's very easy, because the column here becomes the row here, right? So the column here becomes the row here. Here in this case, the row here becomes the column here. But still, going element by element helps because you can do it for rectangular matrices or square matrices. So you've seen this for different matrices now. You've seen transpose for a rectangular matrix, which is what we explained first. You've seen it now for a square matrix, for a column matrix, for a row matrix. That should help you handle any such scenario. Now, another interesting question is what happens if it's a diagonal matrix? So in a diagonal matrix, all the off-diagonal elements are 0. And if you look at transpose, if you look at this case, the diagonal elements don't change. So for a diagonal matrix, the transpose of the matrix itself, right, is the matrix itself. If you take A and A is a diagonal matrix, then the transpose A bar is the same matrix because the diagonal elements don't change in a transpose if it's a square matrix, and the off-diagonal elements are all 0. Now we'll cover this when we look at another video on transpose matrices. transpose of matrices, where I'm going to go through certain properties, right? But I thought it was an interesting fact to mention. So now that you're thorough with transpose of a matrix, please go to teachyaar.com and take a quick test, and I've posted a screenshot of the test here. It's a free test, and at the end of the test you will get some feedback also on those questions. So it's a good way to make sure that you have understood the topic. To take the test, just scan the QR code here on your mobile device, or we have dropped this link that I'm showing you in the discussion and the comment section. Just feel free to click that and take the test. And please subscribe to the TeachYaar YouTube channel to get notified as we add more content.